check.
Ik vind toch dat die lampjes moeten gaan werken. Dat is een mooi Internet of Things project. Gewoon even van die lampjes, op welke camera we zitten. Ik ben live.
Ja.
Kijk. Misschien moeten we ook een lampje met on-air hebben. Voor de volgende keer. Oh, dat is als Jelmer zijn biertje omhoog gaat, zijn we on-air. Oké. Hey, welkom terug iedereen. Voor het after dinner dip slot. And the rest we'll do in English for the people that like English better. This is the after dinner slot, but also the Jelmer found something cool on Kickstarter slot. And then we usually invite them. And this one was this time for you with a cool Internet of Things device. So that buzzword bingo word is also out of the window.
Checking the box.
Yeah. So please give a round of applause for Niels.
Thanks for having me, guys, and thanks for the invite. Of course, I'm happy that we managed to that someone was able to find us on via Kickstarter. So that's at least a good sign. Well, in the meantime, we did already completed the Kickstarter, and we managed to collect 23,825 euros. So that's a good success. It's over 200%. So we're really happy. It's about a Internet of Things developer board with LoRa communication. I'm just curious who in the room knows what LoRa is. LoRa communicate. That's a good score. Thank you so much. Who has worked with it before? That's a few. Okay, cool. Okay, that's cool. So I will be doing a live demo. So let's test Murphy's law. I'm curious how it will come. I just tested it myself in the back of the room and it worked. So just to cover myself a little bit. I wanted to give you a little bit of a context where this board came from and why we made this. So I got some extra time to talk about this. So I actually want to take you back want to take you a couple of steps back where this board came from, and it's actually this place you see on the picture here. It's called the RDM Makerspace. Has anyone perhaps heard of the RDM Makerspace before? One, that's also a good score, relatively. Thanks. So the RDM Makerspace is a company, and we're based in Rotterdam, in the port. RDM stands for Rotterdamse Droogdok Maatschappij. It's a beautiful Dutch word. It stands for the Rotterdam Dry Dock Company. So they used to produce ships there from the 1904 until 1980. It's a very big dock. With multiple buildings, and this is actually the ship assembly line. Multiple numerous ships for the Holland-America line were made here, and also the SS Rotterdam is. Does anyone know the SS Rotterdam? Yeah, it's a hotel boat in the harbor of Rotterdam. You can rent a room there. Made here. So in this place we have the entire space here on the floor, and it's called the makerspace. And of course you're familiar with the makerspace. So what we do and what we have is machines, and we teach people how to work with these machines. So we make technology accessible for everyone, and hereby we want to stimulate innovation. Think of it as when you look back in 93, when everybody bought a personal computer, development went sky high. Well, we are trying to sort of do the same. It won't be the same scale, but at least offering these technologies to people is a good thing. So we have metalworking machines, woodworking machines, but we focus mainly on digital manufacturing. So everything that involves a digital model and a machine that converts your digital module into a physical object. So robotic arms, laser cutters, CNC mills, and so on. So how it basically works, it's that we always explain it as we are a workplace with a gym concept. So you can take a contract, and based on the contract you can use the machines you don't have at your own place. But then at our place you don't come to work out but to make stuff. Yeah, so we offer, you get a monthly subscription, you take a course for CNC milling or for robotic robot arm manufacturing. And the moment you have the idea, and we as well, that you can work with the machine on your own, you are free to go and build whatever project you want to build. So there's also places which you can rent. So we attract a lot of entrepreneurs and startups who actually need space to build stuff like drones or autonomous flying drones, but also sailing drones and artists. And it's a very broad scale of people who attend there. And I want to take you back a little bit more in history. Does any one of you know who this face is? I guess not. It's Gordon Moore. Gordon Moore rings a bell, yeah? So who said Moore? Yeah, nice. Yeah, see, you were actually the first one who recognized the face. Very good. Yeah, exactly. Gordon Moore, one of the founders of the biggest chip manufacturer, Intel, in 1963. He made the prediction that each year the computational power of the computer chip would double because of the amount of transistors that would fit in a chip would double every 2 years. We have neatly followed this curve, so the somewhat more aged people here in the room will maybe recognize the processors that are over here, and we all recognize the newest one of late. This is of course a logarithmic scale, and this might seem very obvious, but I always like to give the example of what the logarithmic scale translates to if you plot it on a normal. It's exponential growth. So what does this mean? It means that if I stay, of course, we all know what exponential growth is, but to give you the best example I've heard to sort of physically make a visualization of what it means is that if I take 30 steps, I'm walking 30 meters. If I take 30 exponential steps, I've been around the world more than 10 times. Yeah, so that's what we see in the processing power we have available. So that means the last couple of 1 or 2 years, we gained so many computational power that we can do like amazing things, and of course you are the living embodiment of this advancement. And I want to show you a couple of quick examples. So I don't know if you know the Grade 2 supercomputer, 1985, 3.9 gigaflops calculation power, $60 million in price. 3 years ago, factor 20 in calculation power and a factor more in price, and it fits in your pocket. It fits in your pocket. So that's one of the ideas. Of course, drones for sale everywhere. But the funny thing is that a lot of these technologies that are being buzzed out nowadays, like IoT and like robotic arms and 3D printing, which was already past actually. The technology on its own is not necessarily new. So this is a picture of MIT, and they had in 1980 they had already a 3D printer. Yeah, they already had it there. But so that's not new. But what is new? The new thing is that we have the calculation power, so we can have very easy and accessible software programs to operate these machines. Anyone knows this website? Tinkercad.com? Who knows it? A couple of people. Tinkercad.com. It's a in-browser CAD modeler. When I started studying around 10 years ago, you had to buy a very expensive big-ass laptop from the Media Markt or even another place, even better another place, and it cost you more than 1,000 euros to do some proper CAD modeling. Of course, you cannot do proper CAD modeling in this, but you can do CAD modeling, and to quite some extent as well. From this, you can create the STL file, which goes into your slicer for your 3D printer. So this is just to illustrate what has changed. What's changed is technique has become way more accessible. So what we see here is a robotic arm manned by a young man from, he's a graduated architecture student from the TU Delft. They have a Studio RAP, and what they do is robotic architecture production. So with robots, they make all sorts of architectural objects. So what you see here is the production of this object. So, and I wanted to show you a short video, because this is the perfect illustration of what we can do with this calculation power if you combine it with. Oh, this is of course on one screen. Wait. So basically, what they did, they made an algorithm. And that was a parametric model, and you can just enter the sizes of your building, that there needs to be a pillar here, and then the software reproduces the entire structure. You can just change the beginning parameters, and the entire model will be plotted accordingly. And also, not only the entire surface is meshed, and each triangle is unique in the structure and has a unique connection to its neighbors, and it has a unique corner to each of its neighbors. So it's quite a I think it's a beautiful example of what you can do if you have the calculation power and the machines for it. So this is really what we are trying to achieve at the RDM Makerspace, right? So based on the Makerspace, what we want to do is we have this place where all these people come and make all these things. So we want to make Technique more affordable for people, or more accessible for people. So we do that on 4 domains mainly. So the first one is drones. We have a big open space so people can fly, develop and test drones at the RDM. 3D printing, but not of plastics, but of metals. This is actually a pillar which is 3D metal printed with this type of printer. It's an arc welding printer, metal printer. So it actually is a MIG welding torch, and it just does FDM, so fuse deposition modeling, layer on layer on layer, 2.5D actually. But you can recreate really amazing things. This is a collaboration with the harbor company, Port of Rotterdam, and a lot of maritime parties involved. So they want to make spare parts for the maritime sector. Yeah. So if you have a big ship, you come in the harbor. It costs you a lot of money to stay there for a couple of days, waiting for a spare part come out of China, taking over weeks. With this, you can make it within a week. You can create a part or repair a part if you want. So yeah, this is one of the projects we have running. And the robotics arms I showed you already before. And the reason, of course, why I'm here today and why I'm almost getting to the point. The Internet of Things Academy. Does anyone perhaps has heard of the Internet of Things Academy? I see a couple of people nudging. That's also good. Internet of Things Academy is an independent foundation. It's started by the RDM Makerspace and KPN. The goal of this foundation is to stimulate the development of IoT on the market. Yeah, so IoT is and will be very big. It's a very big domain. A lot of different parties involved: software, hardware, backend, server, end customer, security, and all these things. All these parties need to collaborate, and there are not many companies nowadays around that can deliver the entire chain from A to Z. Make a customer enthusiastic about the IoT, explain him the concept, take them through the entire process up until the end that you have a skilled solution where you can make thousands of or tens of thousands. Yeah. So this is really what we want to do. So it's an open partner model. So a lot of many companies can have already became partner, like ABM, KPN, Batenburg, uReason. It's all different companies doing something with IoT, either programming software or making hardware production or selling electronic parts like Conrad. So what we see happening with IoT, of course, this is not very new to you either, but we always explain it that this is sort of the 4th industrial revolution. Others call it smart industry, others call it whatever. Yeah, so opinions differ about this, but I always like to show this scheme that in 1784 you had the steam machine, then the electrical motor, then the computer came, and now we have the cyber and the physical world moving more and more into each other, right? So you have these algorithms running in the cloud, which have sensor networks that measure stuff in the world, and they automate and make our lives more easy and simple. So in this IoT Academy, in this Internet of Things Academy, we have mainly two activities. The one is creating demand. So we go to customers of our partners. They need to be, they need an explanation of what IoT is, and we use little bits for this. Who knows little bits? Yeah, it's clickable Lego bricks. Each brick has has its own electrical function, and you cannot do it wrong. Yeah, you can do it wrong, but you cannot break it because it's sort of childish. It has a childish character, but it works brilliantly. Because what we do in a workshop is we build your own first IoT solution within 30 minutes, which is a smart doorbell. So you press a button on the table and you get a text on your phone that someone is at the door. And this works really well as an illustration for people to understand what is data, what is a sensor, how do you go with this, where do you get from A to B, and what happens after, and where do you go then. And because you configure this yourself, you get a really good grip on what's possible. And so this is one part. The second part is that we organize, or we stimulate the supply for IoT by enabling developers to come up with solutions that fit the demand. So we organize LoRa workshops to help developers understand what is LoRa, how can you get started with it, and that has been one of the main reasons why we came up with this board. I'm gonna skip this for now. So Marvin on Kickstarter. I will show you the Kickstarter project, which is here. I just got the comment that I'm not allowed to show a video of myself, and I think it's quite lame, but on the other hand, I trained very hard to capture it in a short amount of time, what the board is and what it does, so I'm gonna be lame and show you a video of the Kickstarter page. But It'll be short, no worries.
So you trained for it. Can you explain a bit about how that Kickstarter process goes?
Yes. So it started with an idea. It always starts with an idea, of course. So there was this demand out of the out of the municipality of Rotterdam to show there was some budget, and they wanted to show that stuff was happening in Rotterdam concerning new technologies, innovation. There was a roadmap to the next economy written by some parties, and one of the things was blockchain, which was explored by V2. It's a very creative sort of institution or collaborative between artists and programmers trying to exploit these new technologies, see what comes out of it. So they were having a sort of a blockchain demo, and we were asked to demonstrate Internet of Things. What can you do with it? So we came up with the idea to make a board which is really easy and plug and play and accessible, and just it needs to be as easy as possible for people to get started with IoT. So at first we wanted to do this on the Pi Zero, Raspberry Pi Zero, the $5 computer, which is not available anywhere because they produce it in very small batches, and it's I only have seen it for $15. So, but anyway, the plan was to make it for $5, a computer accessible for everyone. We wanted to make a shield on top of it with a LoRa module, teaching kids how to program, showing the world how to program, how to get started with LoRa, and so on and so on. Later on, we realized that if we wanted to keep it simple, the board on its own would probably run on Arduino or C++. And have Arduino in the core because it makes it easier, open source development and so on, a more bigger community. So we made some choices along the way, and we scaled it down to a very simple board, which is a USB pluggable device. It runs on a 32U4 for the people who know it. It's an Arduino Leonardo chip. It has growth connectors, which are a universal way of connecting sensors to the board, and it has a LoRa module and some regular Arduino pinout. So the idea is that you can plug it in your laptop, you can plug in a sensor, you download the right Arduino code, you plug it in the power bank, and it works. As easy as that, right? So that was the goal to create it. So that's a bit of the story, how Marvin came to be. So I'll just quickly run through this. And I'll hand this to you. You can give it to the whole.
My name is Niels from RDM Makerspace, and I want to tell you something about our product. The Marvin board is super easy to use because we designed it to be plug and play. It's connected to your laptop, plug in a sensor, download the online approach to configure your device, plug it into a power bank, and you've created your very own proof of concept. From our experience, Marvin can be used by anyone with the use of our online tutorials. For example, one of our first prototypes was used by Blue System to measure the air quality in the center. Consultants from KPN and Accenture use Marvin to enable their customers to get started with IoT. And students from Nextdoor measure water flow in a water flow zone. We embedded Marvin and RDM Makerspace together with one of our members here. Together with our partners at IoT Academy, we will bring Marvin to the market through this Kickstarter campaign. Later we will have production. Volkswagen will ship Marvin all over the world. And if you back up in this Kickstarter campaign, we will provide you with keys to the KPN LoRa network. So back us now, we can scale up production, you get easy and affordable access to the world of IoT.
Marvin, does anyone recognize this? I actually hope that someone in the room knows the name Marvin. From what do you know Marvin? Thank you, sir. Did the logo help you to recognize it, or did you easily? Marvin is always the okay. Thanks. Yeah. So that's of course the link we had with the name Marvin. Yeah. So. So yeah, we actually did the development. I really wanted to show you how it's made. That was one of the questions I got. So this is the early development. So this is actually how we started off with Marvin, right? So here it was called a LoRa Pi, and it was a shield. So you have the pinout from a from Raspberry Pi. Then it evolved into a board which had a sort of onboard antenna. Didn't work really well. Then we came with the idea not to use Raspberry Pi, but go for Arduino. So then we made this design. Then we made some minor changes. Then in the end, we ended up with a chip antenna which actually performed better than the SMA antenna. And it saved cost and size and form factor, so that was a very big convenience. So for the people who know hardware, this is what it is. So it's the RN2483. It's a very common LoRa module. There are more available than this, but this works as sort of as a modem, so you can just implement it on your board and you can talk with it over a very easy serial protocol and just give it commands to send certain types of data or flash in the keys or whatever thing. So we wanted to make it easy. There are more boards as this like this available, but what they all have in common is that it takes quite a lot of work to get them to work. But we wanted to make it easier to do so. So that's why the USB look really helps, and also the functionality of it. And there's different ports available which are common in Arduino. So yeah, the idea of course for LoRa, luckily most of you know it, so I won't go into much detail here, but it's long range, power efficient, low cost, small size. So it's a big catalyst for IoT development, yeah? So with minor investment, you can create solutions that have a big turnout for your company. In workshops, what we often ask companies is, what are the most expensive processes you have currently running? Where do you lose most of your money? That's often where you can very easily, the low-hanging fruit, implement some sort of sensor that measures something that predicts data or that can automate things. So this is a lot of slides, but I'm going to go through them quickly. So this is actually how we did it. We did the development of Marvin at the RD Makerspace at our own house. The first 200 pieces were produced at the RD Makerspace with our own pick and place machine. It started with this, really a pin set, and then putting some wet soldering paste on it with a stencil and then placing it all hand by hand. Was done with the first 30 ones. It's a lot of work, but it's fun to do. So many modules, many work. So this is actually the setup we used. So here, you can't really see it, but here's one of the boards. And then some paste on it, and I actually have a video of this, I believe. Oh no, wait. Has anyone ever seen one of these? It's actually pretty cool because it runs on a very simple Excel sheet. You just say, you just say XY coordinates, and then it knows. It's really cool. I actually was surprised by how it works, but it's cool. So then we had an army of Marvins, and fun times. So what do we do with Marvin? Of course, the LoRa workshop. So each month, actually tomorrow night, there's one at the RDM. This one was at IBM. So we really show people in a workshop how to get it up and running. We made a couple of demos. This was in collaboration with KPN for Rijkswaterstaat. And we made 3 test setups, which one was a buoy to measure when it's being bumped into or the light is on or off. The second one was a water height sensor, which just measures the water height every X amount of time. And then there was a tunnel which measures refraction on the surface to say something about the dirtiness of the tunnel, whether or not the cleaning party needs to get involved or not. So we created, yes?
So the LoRa, is it like a wireless protocol, or is it like
Yeah, good question, thank you. It's basically just as 4G, Wi-Fi, all the other wireless communication protocols. It's just another one. Only this one consumes extremely little amounts of power, and it can go over a very large range. So from a device to a gateway, you can go over 15 kilometers, which is actually extremely big, kilometers. So you need a very lowly populated network to cover the entire Holland. So KPN did this. Last June their network was launched. There's also an alternative, the Things network, a lot of people will know that as well, which is based on users. So if you want a gateway, you buy a gateway and set it up, and then together with all the other users you create a network. So it's a bottom up and a top down approach. Why it's so energy efficient is because the module sleeps all the time, and the moment it needs to send a message, it just wakes up and it broadcasts it. It's not a point-to-point connection, but it's a radio communication, so you just shout a message in the ether and the nearest gateway will collect it and then figure it out where it needs to go. And then it goes back to sleep again. And yeah, you really only consume, you have the time it takes to send out a message is about like 20 milliseconds, and then you consume only 20 milliamperes and you sleep, or you are actually turned off, so you don't consume any power when you're waiting. So yeah, you can with like a simple battery, you can go a really long time. So that's the idea. So, and because of the module is like for now it's still quite expensive. This module costs 10 euros a piece. But in the future this will drop around 5-6 euros. So let's say for like 20, 30, 40 euros you can create a node of which you want to have thousands, which you can throw at the wall and at your machines to make these sort of sensor networks. Yes?
You say it just shunts the ether. How reliable it is actually so that the message is captured?
That's a very good question. At this point in time, when you're outside, you have a 100% success rate. There is notice of a certain packet loss that occurs, that happens sometimes. It has to do with the network. It has to do with the network, with the module. So these are things that will be eventually worked out. You can do a lot on server side, of course, software programming. I lost the word, but that you send the last few packets along with the package you send, so you always know when you miss someone. So yeah, it happens. That's true. But I must say it's very reliable, especially when you're outside. They give a guarantee that how do I explain this? Not going into detail. So let's say you have a quality of your connection and it ranges up from 0 to 100%. KPN guarantees that you have 80% quality of connection when you're outside, so that as long as they manage that, then the last 20% can be reached when you're inside. But that's not always the case. So I'll send it in a little bit. It's probably good that I'm next to a window, because if you are in a room with no light, then there chances are that you use 868 megahertz frequency. So yeah, it is a type of frequency that has troubles with concrete and metal coating windows for some stuff. Yeah, it's be careful. Sorry? No, it's two-way. Yeah, it's bidirectional. Yeah. Yeah, so it sends out a package and then it listens for two short time slots. And there's 3 modes. So one is you send and then you receive. The second one is each a set time per hour. You start listening and you listen if something comes or not. And the third one is that you listen constantly, but then the whole low power point is gone. So then you need to be close to a battery source or like a net supply. So what we do is actually we didn't want to just create a module, so we wanted to go one step further. So this is actually what you see here is a dashboard from Node-RED, which runs in as a service in Bluemix. How many of you know the IBM Bluemix platform? Only a few, yeah, really? And Node.js is known, right? To all of you, of course, okay. So, because IBM is partner in the IoT Academy, they linked to us to their network or to their platform, and they taught us how to work with this. I can show you in a little bit how this works. And this is actually one of the prototypes I made not too long ago. So this, what you see here, is the power bank, which I have here as well. So the code that runs on this one instantly is activated the moment I plug it in. Then here you have a button, and here strapped around it like a bomb is a GPS module. So what this does is that the moment I press the button, it localizes the GPS. Then when it has the right coordinates, it sends it over LoRa and the whole thing goes into sleep mode again. And this GPS is commonly known as very highly power consuming, but actually this one consumes the same amount of power that the LoRa module uses when sending. So it's actually quite an energy, low energy solution. And this is, you can apply this in tons of different ways, right? So which company doesn't have stuff laying out in the field of which they don't know really where it is? Did you know NS doesn't know where certain train wagons are? Or did you know that Rijkswaterstaat doesn't know where certain spoorweg, the big things on the highway? The white things on which the boards are hanging, they don't know exactly where they are. The harbor port of Rotterdam has these very big pushing containers, which are laying around somewhere, and unaware. So if you know where they are and when to use them, it would be nice. These are really easy cases, right? So yeah, disruptive is I wanted to call one a very another nice buzzword, two actually. But why is this? So this is a very small CNC mill with which we can mill copper boards. So we can actually do very rapid hardware prototype production. So this is actually the layout of a drone, a very small drone, which you just can mill out, and then the electronics as well included, and you can test it, and you make a couple of iterations within a couple of days. So because this is going so fast, you can within no time create a new module that has functionality X, right? So this is why it is being called disruptive. And I'm going to round up, and I wanted to show you this image, and actually I want to show you this image. Who knows this website? Not too many people. I'm going to show it because it's really cool. It should be clickable. It is clickable. So this is awesome. So what is this is basically an algorithm learning how to design the best race car available. Yeah, so you have a couple of parameters. The track gets harder over time, and there's a couple of parameters. So you have the wheel size and the weight, and then the shape of the body, and so on and so on. And then each time the population is plotted, and they race each other, and then the winner is taken, and then a new population is plotted, and now it's only one. So you can play around with this a little bit, but really, you can have this running for quite some time. And actually, I had to should have started it this morning and see where it ended up with. But you can say here somewhere, whatever. You can say here somewhere that you want to plot more each time. So, but this is what I want to tell with this is that I believe that combining. This is not working, right? Showing a slide and. So, it's running, it's running. When I'm finished, we'll see where it is, okay? So, I think this is the goal we're heading towards, right? And we all want to achieve this, of course. But combining IoT, simple IoT and extensive AI, I just not too long ago saw a presentation of someone, and he said like the trend that's going on now, and what you see happening is that you have, of course, AI, then you have machine learning, and then you have deep learning. So we train neural networks with deep learning to have a certain functionality. Once the algorithm is or taught, the final algorithm runs on quite little calculation power. So you actually need a very simple node, which has a small amount of calculation power to recognize whether it's a strawberry or not, or whether it's sick or not, right? So this combination is gonna really change a lot of things, because if you could then have a camera module with a very small processor running a very intelligent algorithm, very good at one task, then you can create very valuable solutions. So this is, if you ask me, where we're going. So it's really hand in hand, right? So you need a sensor network measuring the world in a certain way, and then most favorable is having the hardware as simple as possible and all the intelligence in the cloud. But if you can make it in a smart way with combining AI on your device as well, not the whole in development, but the end solution, then you have a very nice solution as well. So I'm out of time, but am I allowed to show a demo? Do you like to see a demo, or are you all done for? Demo, right. Cars. So let's look at this for 5 minutes and then no, I promised you I want. Awesome, right? So it keeps running. Yeah, I'm just gonna do my demo over this. So, who knows Arduino here? Everyone. Nice. Thank you. So, I can show you then even a little bit. So here are, in terms of security, these are my keys. They are on the internet. I don't mind. That's testing purposes. So it's very simple actually. So this is just a very simple program that I can type any payload in my serial monitor, and it will send it via LoRa. Yeah, so that's what's happening now. So I'm gonna upload this to the board. Yada yada. And I'll just show you what happens. So it's actually quite amusing. Yeah. That's a good one, right? Yeah. Wait, yeah, it's running. No worries. So first we have this one, upload complete. Then we go here. So what you see here now is really, that's what I like about LoRa. It's a very elegant and lightweight protocol. Yeah, it's very elegantly designed. So what you see happening here is literally the processor talking to the LoRa module. Really, okay, over serial, over UART. So you send, this is excluded, so you set max set, that's the mac command you give, and then the key, and it says, okay, and then you join with authentication by personalization. It's a certain way of joining the network. You get accepted, and then my program asks me, what is your payload? And then I say, my payload is 1, 2, 3, 4, 5, 6, 5. It's being sent, so now is Murphy's Law. See what happens. So here now, according to the module, it went okay. MAC transmission is okay. So now I go to the developer portal of KPN.
But now it's just in the ether.
Yeah, it just has been sent out. Just has been sent out, unconfirmed. Yeah, just has been sent out. And here I see, actually I don't need to refresh because it's here. So here you see my payload, my uplink, my spreading factor. So this runs from 12 to 7. 7 is very good, 12 is very bad. And this is not my payload. This is not my payload! Nice. I thought that I almost had the same one, right? 445. Okay, let's try again. So just now I also I didn't refresh. Yeah, you're right. Oh, it's still refresh. Hitting the button. Yeah. Nice. Okay, one more time. Probably I just need to tilt my laptop. Apparently it helps sometimes. So I'm gonna show you that this one came through. No. Okay, so I'm gonna. Sorry? Different device? No, I only have no. There's only one. Okay, so one last try is just to physically turn my table that direction. So this is LoRa at this current state, right? So indoor it's meh. I would use the gateway inside, but outside it's actually working really well. No, I cannot show you. So, but to prove a point, I was here, right, from the beginning. I was here at 4 o'clock, 3 actually. So here you see these payloads were being sent out from 1702 to, and that was in the back of the room there. So probably there's some. Anyway, so what happens here? You have this is just a catch. From here you can do an HTTP post to a certain URL. Define yourself. So as I told before, for that we use the Bluemix platform. You can just create apps. It's a sort of, just as Microsoft Azure and other cloud platforms, you can have all these predefined functions which you can connect together in an application. So I used Node-RED as an instance, which is this. And here the LoRa of the message is imported. Then I take out the payload here very simply, which is somewhere hidden in there, and then I post it to here to a website and here to a dashboard. So this is a website showing the payloads coming. Oh, here you see the payloads that I just received some time ago, and this is a dashboard. So this is really easy step. So with this, anyone can start developing, right? So if you now create a solution and you want to start measure something without changing your entire process, you can just plug it in the power bank, put it in the field, and collect some data, put it in the database and store it, and give it to someone who knows how to handle data, right? And you don't need to very long consultancy period involving many difficult things, while it can be as easy as this. So this is IoT made plug and play. That was what our goal was. Depends. If you run it like this with the code written here, it's very not efficient. So it will last a couple of days, but with Arduino you can shut down all these internal things and let it wake up with an interrupt, which can be a sensor or a real-time clock or whatever kind of thing. So you can quite easily create a solution with which you can run it for like a couple of weeks to a month, but around that. But this board is meant for development, right? So we didn't aim with this board to reach these really extremely low power 10 years on the battery solutions, which are promised with LoRa. Exactly. For many cases it is, because then you have a certain valid test amount of time. Yeah. I'm done. Any questions? Yeah.
One sec.
I've got a couple of questions.
Yeah.
One is that I saw specifications of a competing protocol, Sigfox. I don't know if you've heard about it, but they had some.
Yeah. Yeah.
They have some ridiculous restrictions on the amount of payload you can send. I think it's 100 packets of for 40 bytes or so. It's just one UDP packet. What are the restrictions from KPN?
Yes, but that's because there are restrictions from the IEEE actually. And actually it's the LoRa Alliance. So to start from the beginning, it runs on 868 megahertz, which is a license-free spectrum. In order to be able to send on this spectrum, you need to account for two big rules. One is power management, so you cannot send. You can only send for a certain maximum amount of power, and the second one is duty cycle, so you can only send for a certain amount of time, and that is 1 or 10%, mostly 1%. So that means if you talk for 1 second, you need to shut up for another 99 seconds before you can talk again. Well, if you have the best connectivity or the best connection, your packages send out in 20 milliseconds. So then if you recalculate that in LoRa, you could send 300 messages a day around. It's bidirectional. Gateway counts as an end node as well. So if you have 1,000 nodes in your field and one gateway, this gateway can, of course, not respond to all the nodes in the network. A gateway has more channels, 8, and one channel can be sent, has a duty cycle of 10%, so or 0.1% and 10%, so can be both to send more often. So there are restrictions. You need to account for this. So that's why we say LoRa is a catalyst, but not the holy grail. So yeah, you really need to check, does it fit my solution? It has low power, very extreme large range. These are very nice takeaways which you can use in your project, but when the limits of the technology are too narrow, then yeah, of course you need to look to another technology. Yeah.
The other question is regarding the makerspace. I would be very interested in renting the milling machine and the pick and place machines. Is that something I can use there?
Yeah, I have come by later. I'll give you the contact. Yeah, yeah.
Cool. But you can also have then a GSM module on the board, which you then switch on and off with the LoRa.
Yeah,
so
if
if
you
you really have a high payload, like an image you want to upload, because you can't do image data with this.
Oh yeah, sorry. Yeah, so the payload, the size of the payload is also around 50 bytes, so it's also small. So compared to SiC, sorry, 50 bytes. Yeah.
That's quite a lot.
Yeah, it's bigger than Fixbox in comparison.
So you can't do an image with 50 bytes.
No. Very smart array.
Askyard, like our new logo will probably fit.
Yeah, exactly.
Another question.
Beer? Anyone beer?
Beer?
I favor beer.
Then another round of applause. Huh? Cars? Oh yeah, we want to
Cars!
see cars. Yeah, sure.
Of course. Oh, that was almost. I'm quickly gonna try one more. Maybe as a final.
It's also like a nice hacking contest. Whoever hacks like the big display in the hall, and tomorrow morning when we get in, have like the cards run on that.
Yeah.
We'll get a creative beer from me.
So this is close to the optimal car. Actually, I believe the optimal car is like two big black wheels, and then with quite a long in between part. I just need to remember what this. So you actually look up this website because it actually has on GitHub has the entire thing written out. It's actually kind of cool. I believe they have like the.
I'm now wondering why in school I had to build all these scheduling algorithms with genetic algorithms instead of like building cars. It was like the data science department's already figuring out what's the best approach.
We actually had this on for like a week on the screen.
Yeah, right.
So you were clogging our big data cluster with like running this?
So
it's so slow. Oh.
So what was in the end the best car?
It depends because the track is also random. So after you restart it, then the track becomes
Ah,
But actually, the trend is always very similar. That
yeah,
the
yeah, yeah. So
best solution is found really quickly, and then the average starts creeping up, so that the other cars find the same similar solution.
Yeah.
But the trend lines tend to be always
Yeah.
very much alike.
it's amusing. Thank you, guys.
Okay, well, thanks again all for coming. Thanks Jelmer for mainly doing the main part of the organization. And doing the switching and the cutting of the videos and the posting them on YouTube and adding like the new logo on it. So and then still having his day job. So also thanks to Arjen who took care of the dinner, and I think now is looking for bakjes. So there was some food left. So if you still want to take some stamppot home, you can do it and eat it as lunch, or eat it tomorrow as a dinner. Thanks for coming. Next edition, well, I don't care. Maybe in Finland, maybe here. Probably somewhere February already. Depending on like the number of internal Sanoma people that wanted to talk, or until Paul unbricks his device, so we can have his other talk. See you next time. Thanks a lot.